Hi, my name is Kumar Sandeep. I'm here with my team members Manikanta and Chetan Reddy. So, coming to the project outline, this project is all about analyzing and determining the most efficient method for transmitting the power through the lines across the long distances. So, in this case, we are transmitting from South Australia to Queensland with the help of high capacity transmission lines, which can transmit high voltages to far distances. As far as this project is concerned, we take into consideration the three types of transmission options, which are HVAC, HVDC, and that is of current source converter and voltage source converter, among which the thyristor is being used by the current source converter, and on the other hand, voltage source converter uses the transistors. The graphs in this slide represents the VSC, CSC and HVAC when the fault is applied at the North Queensland, whereas the plots in this slide represents the VSC, CSC and HVAC as well, but when the fault is being applied at the Murray link. Coming to the national electricity rules, the typical working frequency range as stated by national electricity rules is set at 49.85 Hz to 50.15 Hz. As per the NER rules, there are two types of connection services, which are basic connection service and the micro generator connection service, where there will not be any augmentation of distribution network.
Hi, this is Manikanta Mane. I am here to talk about the customer reliability and sustainability. So now I'm gonna talk about the three principles which are used in every project. That doesn't matter any project. So these three things will be included in every project so that the project will be very effective and efficient. So first, sustainability I'll be talking about is environmental sustainability. In this, the emissions of the CO2 which are released is measured all the time along the transmission lines and associated with these international standards to reduce the emissions which affects the environment. So all these CO2 gases which are released, these gases will always be controlled and will be monitored with these international standards, with Australian international standards, to reduce the emissions. So there won't be any loss or there won't be any kind of emission, over emissions in the which affects the environment. And later on it will be with the economic sustainability. So in this, considering the few financial sustainabilities of the conductor, replacing the overhead transmission lines, so there should be a proper maintenance of the grids, which can be done like often, very often. So not only like weekly or monthly, it should be very often. So then it will be like social. So in the social, the local communities or the government bodies will be very benefited, and they can also create many employment opportunities to certain people, like local community, or like rather than globally or country wise or nation wise. So these are the three main sustainability facilities which should be included in this project, which can be effective, which can be very effective for in the further process of further future recommendations as well. So the conductor sizing. So when it comes to the conductor sizing, this will determine with the using Kevin's law, when the current and voltages are given. So and the transformer which are transmitted with greater voltage to longer distance. So this will be like, these transformers were like used very often and very reliable. So, and this resistance value of the conductor vary from metal to metal at a different temperatures. What, it doesn't matter with normal temperature, any temperature. So it can be used in these kind of projects. And then the skin effect is also caused due to the conductor depth. So that's why this effect is used. And then the bipolar sulfur triple conductor, this we prefer because it's very reliable, so that's why we used in this project. And the later on slides will be given by my friend Chetan. Yep.
Hi, I'm Chetan Reddy, and now I'm discussing about the possible losses and system stability. The possible losses in our transmission system are three types: residual losses, corona losses, and skin effect. The firstly is residual losses. These losses are mainly due to the transmission line which is operated at low level voltages. And secondly, the corona discharge losses. The losses caused by the air molecules near to the conductor, which are gets ionized with these conductors and leads to the sparks and hissing noise. These are called corona discharge losses, and at this part the capacitor discharge voltage is being reduced. And thirdly, the skin effect. As the skin effect is mainly depends upon the depth of the conductor. If the conductor depth is high, the skin effect is minimum. Now we shall go through with the stability. Now the system stability. The transmission power is subjected to the load variations at some point in the transmission lines. The bus should be well synchronized with the generators which are used in the transmission. It is also referred to the synchronous stability. The maximum power that can be transmitted at particular point on the transmission line is also called as stability limit. And the next one is references. In this we had gone through with these references of some national electricity market, and with some rules like Australian electric market rules, and we had gone through at powerthrough.com and little more like web stuff like that. Thank you for listening our video.